Now we're going to be looking at length of an arc. Now arc is simply this length here, the curved part of a particular sector. This is like a slice of a pizza, isn't it? Now to find the length of this arc, you need to pay attention to the proportion of that sector in respect to the full circle. So you can see that they're giving you a little degree here, an angle, right, of that sector. Now this we call the angle at the center of the circle basically, or the angle of the sector. Now that angle in respect to the full circle, and we know that the full circle has an angle sum of a revolution, which is 360 degrees. So to find this fraction of the circle, to find the fraction of the sector in respect to the full circle, is going to be theta over the 360. And that would represent the length of the arc's fraction, so the fraction of the arc in respect to the full circle. Now because we're interested in length, we need to pay attention to circumference. The circumference of the full circle is going to be given by 2 pi r, so we should all be familiar with this formula here, and we multiply the proportion by that circumference so we can get just the length of that arc that corresponds to that fraction. Does that make sense, guys? So all you really need to remember is the proportion, and you also need to remember your circumference formula. It's 2 pi r, so this is the length of the radius, okay? R is radius. That's what we're going to be doing, so have a good look at that, trying to be familiar with that one. Just remember, guys, as the angle at the center becomes larger, the length of the arc also correspondingly increases. And as the length of the angle of the arc decreases, so it shrinks to a really small size, the length of the arc would also correspondingly decrease that proportion as well. So that's why this angle is very, very important. Alright, so pay attention to that one. So question 1, it says find the fraction of a circle in each arc if the angle at the center is 90 degrees. Now guys, remember the full circle is 360 degrees. So the fraction would be 90 degrees over 360 degrees. Simplify that, it's quarter, 1 over 4. Because we know that 90 degrees is a quadrant, isn't it? So it's definitely going to be a quarter. So what if the angle at the center is 60 degrees? Then you do 60 degrees divided by that 360 degrees. So it's the exact same thing, but the numerator changes. And just simplify it, it's going to be 1 over 6. So that would be the proportion of that arc in respect to the full circle's circumference. Make sense, guys? So question 2, they give you a diagram here. It says find the length of an arc. So this is the length of the arc that we're interested in. And it gives us the radius, which is 1.5, and the angle at the center is 48. So we need to first find the proportion of the circle, of the sector. So it's going to be 48 out of the 360 degrees, and we simply multiply that proportion by the circumference formula, 2 pi r, and radius is 1.5, so I let r be 1.5. And now guys, we've got everything, you just have to multiply everything throughout, and you should get something like this. To 2 decimal places, it should be 1.26 centimeters. That represents this length here, the length of that arc. Question 3, find the length of an arc. So in this particular sector, we know that the angle is 37, that's the angle at the center, and this is the radius, 8 centimeters. And we're interested in this length here, the arc over there. So again, we need to first find the proportion. The angle is 37, so to get the fraction of that arc, we need to do 37 divided by the 360. We multiply it by 2 pi r, r is 8, the radius, and multiply it all together, that's what you should get, and just round it to 2 decimal places for me, it should be 5.17 centimeters. Question 4, okay, find the length of an arc again, so this whole length is what we're going to be looking at. Now you can see that this is a straight line, so the angle sum of a straight line is 180 degrees, isn't it? So that's the proportion. So we need 180 divided by 360, and we multiply it by 2 pi r. Radius is 6 centimeters. Now you can see that 180 divided by 360 is a half, isn't it? Now we can clearly see that that's a semicircle, so it must be a half. Okay, so you can just multiply it by half straight away if you like. And just multiply it, you should get this to 2 decimal places, it should be 18.85 centimeters. That is the answer. So it represents this whole length here. Question 5, find the length of an arc. So it says this arc here is what we want. Now the angle is, it shows you that that's a right angle, which means that the angle at the center is 90 degrees. So we do 90 divided by 360, multiply it by the circumference 2 pi r, radius is 3. And you can see that 90 divided by 360 is exactly a quarter, isn't it? And that's because you can see that it's perfectly a quadrant of a circle, so it must be a quarter. So a quarter times 2 pi times 3 is going to be this. And to 2 decimal places, it should be 4.17 centimeters. So that's the answer. That's the length of the arc. Okay, we'll try another one. Find the length of an arc correcting to 2 decimal places. Now, we need the angle at the center of that particular sector. Now, you can see that they give you this one here, 118 degrees. But is that what we're interested in, guys? That's not the angle that we need. It's this angle inside that sector that we want. So that's the angle at the center. So to get that angle, we need to do 360 degrees minus the 118 degrees, don't we? And that would be the angle inside this, that sector. So 360 minus 118 is 242. So this angle here is 242 degrees. Okay, I'll just write it there. And then to find the proportion or the fraction, we should do 242 divided by 360 degrees and multiply it by 2 pi r again. And the radius is 9 this time. And just multiply all together, guys. You should get 38 point something like that. 2 decimal places, 38.01 centimeters. So that represents the length of this big arc here. Alright guys, so it's quite large, and that's because the angle of the sector is also quite large, okay? So they change correspondingly to each other. Alright guys, so that was pretty much the length of an arc.